Greetings everyone, this is non-expert here back again with another video. Today we'll be solving problem number 19 and difficulty it's been rated at is medium. This problem was asked by Facebook and let's just get down to it. The problem description is a builder is looking to build a row of n houses that can be of different colors. He has a goal of minimizing cost while ensuring that no two neighboring houses are of the same color. So given a n by k matrix where the nth row and the kth column represents the cost to build the nth house and with the kth color, return the minimum cost which achieves this goal. Alright, cool. So if you don't understand what this problem is, it's basically that we will have a cost matrix where the cost matrix is going to be of length, it's going to be into an n into k 2D matrix, and basically, the n part is the house at which we are at, the house number at which we are at, and k is the cost for painting that particular house. And all we want to do is we just want to find out the minimum. Um, so one of the ways, if they sort of do not, so break down the problem first, right? So one of the ways you can sort of look at this is that if you don't consider no two neighboring houses are of the same color, and you just have to find out the minimum, the way to just go about it is just by basically finding out what's the minimum for each of the rows, right? And basically adding all those up, and basically you're done, right? But since we have this particular condition that no two neighboring houses are of the same color, we need to add a few extra logic over here as well. This particular problem sort of comes under a dynamic programming question because there are multiple ways of handling it through DP. But we'll be using a more simpler approach just because of I explained it. You can actually break down this problem and see that we just have to handle the adjacency case. And if that wasn't the case, we would have just done minimum of everything else. All right, cool. So fortunately, we were able to find an online editor which has a similar question. It's called Paint House 2. You can go through the problem and they have given a proper input over here as well. So you can see you have a cost matrix with 2D matrix, and this is what's the cost for painting house number 1, cost for painting house number 2, and cost for painting house number 3. So basically, if you're selecting color, let's just say this is color 1, color 2, and color 3. So if you're selecting color 2, which is of course 2, you cannot select color 2 for the next house, right? Um, and you would be selecting color 3 because that's actually the minimum. So you will be selecting 5 over there. And now you cannot select color 3 for the next house. So you'll be selecting color 2. So basically, when all of these are summed up, you get a answer of 10, and that's what the question is asking us to return as well. You can pause this video and go through the description on your own. It's given in the link. It's sort of given in the description, and you can sort of go through. You just everything else is over there. But we'll get down to the solution. So let's just open our IDE. Yeah, and we'll be coding in Python 3 as usual. So let's just start with just writing a few base conditions so we have something to start on. So we'll just say if there's no cost, we'll just return 0. That's the first condition as usual. And what we'll do is we'll just make a few more variables. We'll just say n is equal to length of the cost, right? And k is the length of cost 0, which basically denotes so this denotes number of houses. Sorry, number of houses, and this would denote the number of colors that we presently have to which you want to paint with, right? Um, so the way we're going to approach this problem is basically by understanding what's the minimum that we found so far, which was in the previous row, and what was the secondary minimum as well. The reason why maintaining two variables, which is minimum, so previous minimum and previous minimum 2, is basically because we want to understand that if I can't select, let's say, previous minimum 1, because it's at the same index, right? If we can't select that, then I want to understand which other color can we sort of select. And the way to sort of understand that would be if we just maintain one more variable, which will be previous minimum index 2, right? So if you sort of take this example here, we'll do a quick try run on what I'm trying to say. So just 1 minute. You can skip a little forward a few seconds or so before I format this. Cool. So this is the to the array which is given to us, and basically we are going to maintain something called as what was the previous min, right? As I mentioned before, what's the min index which we found so far, and what's the previous minimum to, which is basically the second minimum inside the previous row, right? And the way we sort of going to compute this is basically if we, when we iterated through this, when we go on this particular row, the values for each one of these things would basically be somewhat like this. Actually, let me just update this as this. So at the very beginning, we're just going to have 0, -1, and 0, because that's the initial values that we're going to start with. And then what we're going to do is, after the second iteration, the values would sort of get updated, right? So your previous minimum would be 2. The index which it's presently found at would be 1. And obviously, the second previous minimum would be 11, right? And then we're just going to move forward with it. So let's take an example like 1, right? So 1 over here in the next row is basically the minimum value, but we cannot select 1 because we've already selected 2. So what we're going to do is we're going to compute what's the entire minimum when you sort of take previous minimum and or add all of those things in, and just see and just compare it with previous minimum 2. So previous minimum 2 when added up to this thing would be 12, so your previous minimum would be 12. But unfortunately, the previous minimum would still be, I mean, because you can still select color 3 and color 1, and color 3 is 7, so you'll just update this to 7, and your index will just get updated. And that's our entire formulation, right? That's how we're going to move forward with this entire solution. Um, I hope it's clear. I think it's pretty simplistic. If you sort of get the gist of it, you can sort of write this down as well if you're having any concerns while sort of trying to solve this problem. Um, but yeah. All right, cool. Also, we'll be making sure that throughout this particular approach, we are not using any extra variables. So that's one thing which we're going to take care of as well. All right, cool. There is one corner case which we sort of need to handle, which is what happens when k is actually equal to 1. So if k is equal to 1, which is our corner case here, we basically need to return what's the value based on the cost matrix, right? So we would return based on whether n is equal to 1, right? So basically, if you have only one color and if you have only one house, then what would we return? We would return cost of 0, right? It's very self-explanatory, or we will be using -1. So the way to do this is actually through ternary operators in Python. So we'll just use that. So we'll say we'll be selecting cost 0 if n is equal to 1, else if k is equal to 1 and we just have one color, we're just going to negate this entire thing. We're just going to say return -1 over here. And if you don't understand why -1, it's pretty simplistic. That's just how the behavior is. Um, yeah, and let's just get to our implementation. So we have previous min index, and previous min to basically initialize, right? And all we have to do is we just have to iterate through the entire thing. So we just say for I in int of range of n, which is for each and every single house. Now we just want to compute what's the min that we've sort of encountered so far. So let's just make a few variables. Let's call temp min, and then we can just sort of give it any value as such. We could sort of give float or any high value as such. And the way to sort of do that in Python is basically use sys. I'm not sure whether sys has already been imported, so most of the times it is, but let's just do import sys, and we'll just say this is sys dot max int. Oops, max int. Yeah, and then what we're going to do, that's our temp min. We're going to also maintain temp min index, which is going to be -1, and also just call this segment, which is going to be the secondary min and just say and that's it. Yep, cool. And the reason why we're maintaining all this thing is just because we're going to perform some computation for each and every single color that we've encountered so far, right? And let's just get to that. So we're just going to say for j in range of k, basically while iterating through all the colors one by one, we want to understand what the value is. So a value can be computed uh, based on whatever the cost is, right? So if cost is I plus j, right? But we need to also add it with some values. So plus, so we add it either with the previous min, right? Which we've encountered so far, right? And we can only do that if j is not equal to the min index which we've got, right? Um, Else, if that's not the case, if it is equal to this thing, then we would just say that hey, you need to pick up previous min too, right? Pretty simple. All we're doing is we're just going through the same thing which we talked before. Um, and let's just talk about how we can handle other things as well. So there are a few if conditions which we need to understand. For example, what happens when min index is not initialized? What's the first iteration supposed to happen? So if min index is equal to minus 1, what we want to do is we want to understand what the min value is, right? So the temp min at that particular moment of time is just going to be the val, right? So there's nothing more there. And the min index is basically going to be the jth value, which is the color that you selected, the index of the color that you selected, right? So this is just the base case, like what happens when there's nothing which has been initialized so far, and that's the way we're going to handle it. The other case is basically going to be what happens when the value which we selected so far is less than, right? And do note what I'm saying is, it's less than the minimum value that you've encountered so far, right? If that is the case, that it's actually less than the temporary min value that we've sort of calculated so far, then your secondary min is going to become your temp min, right? And your temp min is basically going to be equal to the val. And all you're doing is you're just saying that, hey, if my value which I've encountered so far is less than the temporary value for this particular list, right? This particular row rather, if that's the case, then we just need to update both our secondary min with the temporary min, because temporary min at that point was the minimum, and just make temp min equal to val, right? Because that's the least value. Um, Also, since we're updating temp min, we would also have to understand that temp min index is now going to be equal to j, right? Um, Again, pretty simplistic. And we have one more else if, which is basically going to help us understand what happens when the value, it might be higher than the temp min, but it is actually less than the secondary min, right? In which case, we just need to update secondary min with the value. So a bunch of if-else conditions, you can stop this video and go through it a little bit more, but it's pretty simplistic because we had broken it down. So now at the end of the iteration, all we want to do is we want to update our previous min with min, or rather temp min, our previous min index with temp min index, our min index with our temp, temp min index, and our previous min 2 to equal to our secondary min. Yep. Uh, and that's it. So basically what you're doing is you're just going to check what's the minimum and secondary minimum value for this particular row based on the cost and the previous mins which we've encountered so far, right? Um, and when you do all of that stuff, just maintaining it inside a variable, so you handle for one row, and after every single row has been handled, you just try to understand. You just sort of update the previous minimum and the minimum index and the previous minimum, secondary previous minimum value. Um, and again, it's just based on the rules that we had set. And I think that this should do it. We just have to return the previous min. So we just do previous min, which is the most minimum value after adding everything up. And I'll try to put a few print statement, so it's a little easier for everybody else to understand on what exactly is happening. So for the jth index, you're just saying, just calculating, what's the temp min, right? So far, what's the temp min index, and what's the secondary min, right? And for this thing, let's just we're just going to print what's the previous minimum right now, what's the minimum index, and what's the previous minimum 2, and let's just run this. I think this should help us debug any issues if they come forward. Okay, so it's running. Input is the same. Input has no value. Um, I think it's supposed to be max size. Not sure. Let's just try this out. You could also use float markup to get this, but let's try this out. It's taking a little bit of time, but eventually it runs, so that's fine. You can ignore this value because this is the initial value, and let's just go through the code, right? So for each and every single iteration for every row, so you just have to, you can sort of figure this out, but basically the value at the end is what's important for us. So after the jth index has been sort of calculated, you're basically saying, hey, the minimum temporary value which we've got so far is 2, which is correct. The minimum value of its index is also noted, which is correct, and secondary minimum is also noted, which is also correct. So we update all of those things, which is correct. Then when we go to the next row, basically you can see that the values, the temporary minimum, and all those things, right? Let's just have a look at it. So you have 2, 1, and 11. So basically you have 2 as your minimum and 11 as not your minimum. So what you're doing is you just sort of calculate the 2 with the 11, that's this guy here, right? And you say it's 13, which is fine. Then you have 1, 13, and 0. Basically, at the second iteration, you have 13, which is again fine, and 25, which is also fine. This thing over here is 0 primarily due to how we've handled our condition. Um, sort of gets updated properly later on because of this entire cost matrix and how we're handling it and how we're updating those values as well. So your temp min index right now is 0, which is fine. But as soon as it sort of encounters a 7, basically when it does the manipulation with the last value of the row and gets the value as 7, right, it says that, hey, I found 7 over here, update the minimum index as well, and the secondary minimum value is 13, which is also correct, and it just moves forward from there and just sort of computes everything else. Cool. I think the solution is correct. Let's just try running this in our editor. I'll just comment all the prints. So let's just run this once. Cool, so this is running. Let's try submitting it. Hopefully our test cases should pass if we've not missed out. Okay, unfortunately we're missing out somewhere. Let's just have a look at it. Let's go back a little bit. I think I have made mistakes somewhere. So our min index is here, and oh, okay, so this is my fault. Unfortunately, a little bit of an error coding wise. So this is supposed to be for this particular row, so this is supposed to be temp min index, and this is also supposed to be temp min index, and the min index is just the global min index. I think I should just call it global min index, but I would make sure next time I have that written. But basically we need to update that and use that. So what's happening was that minimum index was getting updated as well, and that was causing all the errors to happen. So logic is still the same, algorithm is still the same. Let's try running this once. So this is for the failing test. It's coming correctly now. Let's just try submitting it, and hopefully it should run now. And it does. Awesome, cool. I apologize for the smaller. That was just while coding it. It got a little tricky. Um, but again, thank you so much for watching this video. I hope this difficult or hard problem has become a little easier for you. Lead code has sort of said that this is one of the more difficult problems, and you would not be able to access this on lead code. That's why I would suggest that you use lint code over here, or whatever link is given in the description, and use that and move forward from there. Again, if you like this video, do give a like and do subscribe, and if you have any comments, do give them in the comments below. Again, if you've already subscribed, you're awesome. We all know it. Thank you so much for watching this video, and have a great day.